Hey guys, welcome to Biddy's Math Binder. Before we start, take out pencil and paper so that you can follow along with me. We're going to be looking at the quadratic formula today. This is a very, very important formula that you must have memorized. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay? This is our quadratic formula. We use this when we want to find x-intercepts. You can find x-intercepts when you solve by factoring. You can find x-intercepts when you solve by completing the square. And you can solve for x-intercepts by using this formula, the quadratic formula. Remember, factoring does not always work. Sometimes you can get a polynomial that is not factorable. Quadratic formula will always work for every type of problem. Let's get started. First, we need to make sure our quadratic is in standard form. So I want to move that 11 over to the other side so that it's equal to 0. Make sure you put it in the right order. ax squared plus bx plus c. So that 11x needs to be moved into the middle. Now, I want to identify what my a, my b, and my c terms are. The a term is always in front of the x squared. The b term is always in front of the x, and the c term is a number all by itself. Now that I know what my a, my b, and my c are, I'm going to plug those numbers into the quadratic formula. X equals the opposite of b, so negative 11, plus or minus the square root of b squared, 11 squared, minus 4 times a times c. So 4 times negative 20, all over 2 times a, which is 2 times 4. So I'm going to plug all that into my quadratic formula. That's my first step. Now I'm going to slowly simplify step by step. So my next step is to say that 11 squared is 121, and negative 4 times negative 20 is positive 320. And then all over 2 times 4 gives me 8. So I'm going to go a step further and simplify a little bit more. I know that 121 plus 320 is 441. I'm going to simplify even further now and take the square root of 441, which is 21. At this point, I've done all the simplifying I can. Now I can break my answer up into the plus and the minus. I'm going to say, what is a negative 11 plus 21 divided by 8? And that's 10 over 8, which reduces to 5 over 4. Then I'm going to say negative 11 minus 21 over 8, which is negative 32 over 8, which then reduces to negative 4. Those are my two x-intercepts. Let's look at another example. First, we want to identify our a, our b, and our c. This is already in standard form, so that's done with. My a is negative 1, my b is 4, and my c is negative 7. So I'm going to take each of those numbers and plug them into the quadratic formula. X equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. So now that that's all plugged into my quadratic formula, I'm going to simplify step by step. First thing I'm going to do is say, okay, 4 squared, that's 16. Negative 4 times negative 1 times negative 7 is negative 28. And then 2 times negative 1 is just negative 2. I'll simplify a little further. 16 minus 28 is negative 12. Now, I simplify further. I'm going to simplify the square root of 12, which we should all feel comfortable with it being 2 square roots of 3 when you do your tree method that you learned in the simplifying radicals unit. Because there's a negative under the square root, we know that that's an imaginary number, so we pull an I out. Now, some of you may want to stop here, but this is not fully reduced. We can keep simplifying. Negative 4 divided by negative 2 is just 2. 2 divided by 2 is just 1. I don't technically have to write 1i. I can just leave it as I square roots of 3. That is fully simplified. Now I can break it apart into my plus and my minus. I have 2 plus I square roots of 3, and I have 2 minus I square roots of 3. Those are my, well, actually you want to say those are your x-intercepts, but you're getting an imaginary number. When you get an imaginary number in the quadratic formula, that means that you don't actually have any x-intercepts because you didn't get a real number to plot on the x-axis. So our solutions are 2 plus I square roots of 3 and 2 minus I square roots of 3, which that technically means there are no x-intercepts on this graph. All right, guys, that's the lesson for today. Be sure to subscribe for more math videos.